Hi, this is Jason Molesky. In this example, we'll take a look at an example of conditional probability in real life. Many women choose to have annual mammograms to screen for breast cancer after age 40. A mammogram isn't foolproof, though. Sometimes the test suggests a woman has breast cancer when she really doesn't. We call this a false positive. Other times, the test says a woman doesn't have breast cancer when she actually does. We call this a false negative. Now, suppose we know that for a particular region, 1% of the women aged 40 or over have breast cancer. We also know that for women who have breast cancer, the probability of a negative mammogram is 0.03, while for women who don't have breast cancer, the probability of a positive mammogram is 0.06. Now, suppose a randomly selected woman aged 40 or over from this particular region tests positive for breast cancer in a mammogram. Let's find the probability she actually has breast cancer. Well, we can first of all start by drawing a tree diagram. We know that in this particular region, 1% of the women have breast cancer, meaning 99% don't. We also know that when they have a mammogram, 97% of those that have breast cancer will test positive, while 3% will get a false negative. Then, for those that don't have breast cancer, we found that 6% would get a false positive, while 94% would get a negative test. We want to find the probability that somebody has breast cancer given they have a positive mammogram. Well, based on the tree diagram, we can see there are two ways to end up with a positive mammogram, depending on whether or not you have breast cancer. To find the probability, we'll have to find the probability of having breast cancer and getting a positive mammogram, and divide that by the probability of simply getting a positive mammogram. What we need to do is find the probability of ending up at each of these ends of the branches. We have two disjoint paths throughout the tree diagram, and I have the probabilities noted here, but how did we actually get those? Well, the probability that you have breast cancer and a positive mammogram is found by multiplying down the tree across each branch. So we'll start with the probability of having breast cancer and multiply that by the probability you would then get a positive mammogram given you actually have breast cancer, or 0.01 times 0.97, giving us the 0.097. We can follow a similar method by finding the probability you end up with a positive mammogram given you don't have breast cancer by multiplying 0.99 times 0.06 to give us 0.0594. So the probability that you end up with a positive mammogram is found by adding those two disjoint paths throughout the tree diagram. 0.0097 plus 0.0594 gives us 0.0691. So the probability you'll test positive regardless of whether or not you have breast cancer overall is 0.0691. So the probability of having breast cancer given you have a positive mammogram is found by taking the probability of both, 0.0097, divided by the probability that the individual tests positive, 0.0691, and we get 0.14. So there's roughly a 14% chance you would have breast cancer in this region given you tested positive. For some additional practice with conditional probabilities in real life, try exercise 81.